Good morning. My name is Chang Song. Thank you for the introduction. Mr. Kang also made a presentation here in this location because standing here I cannot see you well because my height is not that tall. Well, today I want to talk about a startup strategy and new business strategy of KIOST. And specifically, I want to talk about the underwater construction robotics technology development of KIOST. This is a tool that can be used for offshore development. So today I want to talk about this ROV or underwater robotics for offshore development. These are the marine structures that already exist or that are being developed for the future. For example, the offshore plants, marine tunnels, and the CCS that the previous speaker mentioned. Well, the CCS is the carbon capture and storage technology, and sometimes it's referred to as CCUS. And offshore wind power generation and offshore wind turbines and ocean energy facilities and underwater tunnels and overwater bridges. All of these marine structures are being developed and being evolved. But we are installing these marine structures underwater also. And then we need some kind of construction equipment to construct these marine infrastructure. And in the deep sea, we can't help but use underwater robotics because people cannot go into the deep sea level. So these are the robots that are normally used in the deep sea area for scientific purposes. For example, on the left, you can see a robot for survey and exploration of the deep sea conditions, which can go deep until 6,000 meters under the sea surface. And the one in the middle is for the mining of the deep sea minerals, and allowable water depth is 5,000 meters. And on the right hand side, you can see a robot called Crapsters, and the water depth ranges from 200 meters to other deeper water depth. And these are the underwater construction robots. On the left-hand side, you can see that this construction robot resembles a forklift or an excavator. And this is an application that is used for rubble mound leveling or excavation for port construction. And to install various marine structure, we need to have a foundation. And in order to build something on the ocean floor, we need to check the status of the ocean floor. So the facility in the middle is a robot that we use to check the seabed situation and conduct in situ test, and the allowable water depth is 100 meters. And all these robots go 100 meters deep inside the sea. I am currently responsible for the MOF's R&D project. As I said, there are many marine structures that we are using at the moment, but human beings can go deep inside the sea until 350 meters. So beyond that point, we have to utilize equipment or underwater robots. But we lacked homegrown technology to develop these underwater construction robots. So about 10 years ago, this project started. In 2013, we started this project to develop underwater construction robotics for constructing marine structures at a target water depth of around 3,000 meters or 2,500 meters. And we wanted to overcome the Death Valley period and really commercialize this technology. The total public budget was really huge. The national budget amount was 67 billion and the local government budget was around 20 billion. And we also received some private funding. So in total, the project budget was about 110 billion Korean won. And we named the robot URI. URI in Korean means we, and URI or URI stands for Underwater Robotics. And it's. So there are three types of robots: URIL, URIR, and URIT. So URIL is for lightweight work, and URIT means it's a trencher, and URIR means that it's a rocker. So URIL looks like this, and it is a robot with a cord, and it will be carrying out mechanical works and maintenance work, and it also has a smart ROV function and visual surveying function. So even though it's not a fully automated robot, it has semi-automated functions because underwater, GPS technology cannot be used. So without using GPS, this robot will be able to be semi-automated in terms of its operation. So as you can see, it can support the installation of marine structures like this. This is the purpose of URIL. The first stage of development took about 6 years, and the second stage took 4 years. And normally, we would be finishing the research work in 5 to 6 years. But in our case, we already had a lot of research already conducted, and we were able to receive a lot of budget. So we were able to start the production of other robots in the 4th year. And this robot is a robot that we developed in 2017. In Pohang, we created a water basin like this, and we created this for test purpose. You can see the ROV is in the water being tested. In 2018, we received a mission from Company P. There was an oil well that has to be destructed, so they asked us to identify the location of the oil well. So we didn't receive any we didn't charge for this mission, and we only received report for the result. So here we use this URIL robot to check the location of the oil well. And as you can see, we developed a waypoint tracking technology, which is one of the smart ROV functions that we have for URIL. So these smart ROV functions are embedded in this robotics technology. Once we lay the cables, we have to bury the cables under the ocean floor. So normally we will be using water jets and excavate the ocean floor using the water jet so that we can bury the cables or pipes under the ocean ground. And then we would be maintaining the cable and pipe afterwards. And the horsepower is about 900, and the water depth is 2,500 meters. And this robotics, which is a URIT, which is a trencher, is a very highly efficient robotics. We also manufactured this robot in 2017. We conducted various tests. We conducted tests according to different water depth levels. And in 2018, in the East Sea, we had this test of burying the cables under the ocean ground. And we also invited an external expert to really verify the performance of this robot. And this is the menu plate that we created. There is a company called Jang Robotics, which accounts for more than 90% of the market. And they even offered to purchase our technology. So this shows the high level of efficacy of our technology. So we were able to check the performance of our tools like this. The next one is URIL, which is a rocker. And the depth is only for 500 meters. And here you can change the tools on the robotics. And using these tools, you can excavate the ocean floor or make the ground level, or you can also break the rocks or the bedrocks under the ocean. And there is a underwater camera, and it has a 360-degree around view sonar system, which is quite efficient. And just as an automobile autonomous driving vehicle, it has this kind of a sonar system for 360-degree around view. So this is the picture of the rocker, and as you can see, with the tools attached to the robotics, breaking the bedrock is also possible. In the Pohang Center, we were able to test the performance of breaking rocks like this. And in Jeju Island, we also tested underwater performance. And we also tested how cable burial function works. So 3 years ago, from 2017 to 2018, we conducted all these tests. So then what are we doing nowadays? And this is the picture of the water basin in Pohang. And in order for us to really conduct a test underwater, we need a barge ship. And the cost of borrowing those ships is too high. It's almost 100 million per day. So we thought we need this kind of a water basin to really continuously test the performance. So with the financial support from the city government, we were able to create this facility. We don't have a crane that can carry more than 10 tons of weight, so we installed this facility. And the tank size is 20 meters in length and 5 meters in width. And this water tank has the function to create a water current. So it is very good in assessing the performance in different current conditions. So this water tank is equipped with all these costly equipment for efficient testing. So, of course, testing of the robots is important, but we also need to think about marine equipment. Mr. Park also talked about the importance of marine equipment, which accounts for 10% of the market. So we need to also think about how to develop marine equipment, and we also need to think about how to conduct training to develop future talents. So even though we haven't received the budget, Yet, we are constantly consulting with the local government and also the Ministry of Ocean so that we can continue to provide training to develop future talent in this industry. So in 2019, 2020, and 2021, what did we do? As I said, we need to overcome the Death Valley. Most R&D projects will finish at TR6. It's really difficult to move on to TR7. But for commercialization, we need to cross the Death Valley. And as I said, the second stage project was for record making, and we were able to receive budget, fortunately. And underwater excavator, you might remember the excavator with a water target depth of 50 meters. So we also developed this equipment called UX 100, and we could just be complacent in making one record of use using these robotics technologies, but we also developed this undersea water pipe. Up until now, these water pipes had many challenges and problems because the cost was too high for maintenance, and there were also limitations in terms of supplying drinking water. So we used URIT and URIR to develop undersea water pipes, and based on the development, we were able to also apply this URIT technology in Vietnam. So we were able to successfully sign a contract with a Vietnamese organization, and I was told that it was the first case to really sign a contract, commercial contract, for an R&D project consigned by the MOF. So we felt really proud about that. As I said, the URIL had a target depth of 2,500 meters. So we have been recording our works that we have been conducting in this water depth. And this is a vessel that we are going to launch soon. We have many vessels like Onnuri and so on, but this specific vessel is a vessel that supports the construction of marine structures. Especially the DP2 system is required to overcome the wave height, and also Aframe is important. This Jang which this vessel has an A-frame of 60 ton. And to borrow this kind of vessel, it is very costly. It will take about 60 million won, but as we develop this technology, the cost will be halved. Using URIT and URIL, we were able to carry out these kinds of operations on the Jang, our vessel. So this is the end of my presentation. But just as the previous speakers mentioned, I think there are many challenges that we need to overcome in the maritime sector. Aside from scientific development, we are conducting many research on how we can develop new businesses. And in the journey, we inevitably face many challenges. So I want to really admire the hard work carried out by researchers at KIOST And I would like to say that in order to overcome the debt value and come up with a startup strategy that is actually beneficial, we need continuous support from the government. Thank you very much.
감사드립니다.